Hi everyone, my name is Deborah Chen, and I'm a product manager on Azure Cosmos DB. I'm excited today to deliver today's session on how you can achieve good cost and performance with elasticity. Elasticity is a core differentiator of Cosmos DB, and what it means is the ability for you to automatically scale up and scale down based on your workload traffic. Cosmos DB does this automatically on your behalf while maintaining industry-leading SLAs on throughput, latency, and availability. Today's session will cover 3 very concrete, actionable tips you can use to improve your cost and performance today. We'll talk about how you can leverage autoscale and a new feature called dynamic scaling, which optimizes the scaling of autoscale for workloads that have different traffic patterns across regions or partitions, and can help you lower your costs. We'll talk about best practices and guidance for choosing the right partition key, and show a demo where you can see how much of an impact it has on both your cost and performance. And finally, we'll talk about how you can optimize your data distribution with Partition Merge. For today's session, let's look at this in the context of a real-world customer scenario. So today, we are all part of Contoso Retail, and we have 2 workloads that we're going to look at and optimize. The first one is a shopping cart workload for an online retail store, and the second one is an IoT telemetry workload that captures device telemetry from Contoso's warehouses. Let's start off in the Azure Portal, where I have my shopping cart container. You can see the shopping cart is partitioned by cart ID, which is a good partition key in this case because it has high cardinality or high number of distinct values. And when you typically query for a shopping cart to show on the display page for a user, you typically query by cart ID. You can see this is the schema that I have. And currently, I have provisioned 10,000 RUs autoscale on this. Autoscale is a good choice in this case because we know retail workloads tend to be variable, and it's hard to predict exactly the throughput you need. So having a good 10x scale range that autoscale provides is really helpful. Now let's take a look at how our workload is actually running in production. I also have this workload set up in 2 different regions, East US2 and West US2. And today, the workload is just operating in the US, but in the future, I can expand to any other regions in Azure. And if I choose to add a new region, Cosmos DB will do this automatically. So which means that as my workload is running, my data will be available in that region, and I can take advantage of that to provide a better user experience to the app and to the users in that region. So let's take a look at how our workload is actually running in production. First, I'm going to go to my Azure Monitor Metrics section and filter to my shopping cart container. Then I'm going to look at my total requests. So what kind of traffic pattern do I have across my region? Okay. Here, the blue line represents West US2, and the pink line here represents East US2. I can see that over time, my workload is actually different across all of the regions. Sometimes East US has more traffic, sometimes West US has more traffic. So what does autoscale do? If I look at what autoscale is doing today, I use the provision throughput metric to see how much autoscale is scaling at any moment in time. However, it looks like regardless of the traffic pattern, in each region, autoscale is scaling to the same RUs at every point in time. So why is this happening? Let's take a look at how autoscale does this today and how we can leverage a new preview feature to get better scaling at a per region level. Today, autoscale scales each region and partition you have based on the most active one. So this works really well when your workload is very uniformly distributed across all the regions and partitions, but not so well when your workload isn't, which is the kind of workload we have here for the Contoso Retail. In order to fix this, you can leverage a new preview feature called dynamic scaling, in which autoscale will now scale each region's throughput in the partitions independently. This makes it a great fit for non-uniform workloads. So let's see the impact of this in action. First, I'm going to make sure that I have the feature on. So the feature will scale each region and each partition independently. So you go to your features blade and make sure the feature is on here. Now, I have an account where I've already enabled this feature, and I've actually run this workload quite a bit for a while. And I can see, once again, I have a different traffic pattern between East US and West US. Okay. Now, however, because I have this autoscale dynamic scaling feature on, if I look at my provision throughput, which again is what autoscale is scaling to at any point in time, I see that each region is scaling differently. At the times that East US2 is less active, East US2 is only scaling to what East US2 needs and West US2. That means previously, rather than scaling everything based on whatever is most active, we now scale each region based on its actual usage pattern. This means that everything here, this delta, is what you were previously scaling to and paying for before, which is now all cost savings for you. Okay. So if you have an autoscale workload, please check out the dynamic scaling feature to help you save cost on your non-uniform workloads. In this section, we'll talk about some best practices and strategies for choosing the right partition key for your workload. A good partition key in Cosmos DB will make sure that your queries are efficient and that you have good performance. If you have a good partition key, it ensures that there's no bottlenecks on hot partitions, and it also makes sure that you can really take advantage of the throughput that you've provisioned. Let's dive into Contoso's IoT workload and see in practice via a demo just how important the partition key is and how it makes a big difference on both cost and performance. Switching over back to my portal, here I have a database called Partitioning Demo with 2 containers in it. Both of them store the same exact data, some device telemetry data here, but there's one key difference. This container here is partitioned by date, while this container here is partitioned by device ID. In general, when picking a good partition key, you want something with high cardinality or something that has many distinct values. When you compare device ID and date, even though it would seem like both of them have high number of distinct values, the reality is we also need to make sure that at the per second level, at any point in time, it has high cardinality as well. As a recap, Cosmos DB, when you insert data into the database, looks at the partition key value of the document you're inserting and picks the right underlying physical partition to store your data on. This means that if you have a partition key with many distinct values, Cosmos DB will actually hash those partition key values and distribute them evenly across all the underlying physical partitions. So in this example here, I provisioned my container with 50,000 RUs each, which is a lot of RUs, but I really want to exaggerate to show you just the impact of how the partition key makes a difference. So I'm going to switch to my VM here and run a data generator. And all it's going to do is insert some data that looks like this into the Cosmos DB container. In this first demo, I'm going to ingest data into my container that is partitioned by timestamp or date. Now this means that today's date is the same for every single document. And you can see that as I start writing data, I'm really getting bottlenecked on the amount of throughput I can achieve. This is because all of the data is being written to the same physical partition because they all have the same partition key value, which is today's date. Now this means that even though I provision 50,000 RUs, I'm only able to actually use and leverage 10,000 of them, which is actually a lot of wastage there. So how can we improve that? If we instead partition by something with higher cardinality, both across time and within at a per second level, like device ID, say I have thousands of devices that we are collecting telemetry for, you can now see that I'm getting much closer to the 50,000 RUs that I actually provision. In general, when you're choosing a partition key for Cosmos DB, definitely encourage to put some thought into it. Choose a key that optimizes for your workload pattern, and try to make sure that the key ensures an even distribution of storage and request volume. If you have a write-heavy workload like the one we just looked at for Contoso, you want to really choose a partition key that has high cardinality, both overall and per second. Things like device ID, vehicle ID, things that have lots of distinct values. If you have a read-heavy workload, you typically want to choose a key that you can use on most of your queries, while still ensuring that that key has high cardinality as well. Now let's move on to the third and final strategy I'd like to share with you today, which is on how you can optimize your data distribution with another feature called Partition Merge. So what are the scenarios where this feature is relevant? If you as a customer have ever deleted a large volume of data from your containers, maybe you realize I don't need to store 3 years of data anymore, I just need 6 years of data in my container, or if you've ever just accidentally scaled up really high, and then now you want to lower your RUs because you realized you actually didn't need that many. So let's take a look how Partition Merge can help with both of these scenarios. As a recap, Cosmos DB distributes our data across all the physical partitions in order to guarantee scalability. For example, here I have a container with 50,000 RUs, and the data is currently stored among 5 physical partitions. This container is pretty well utilized. Each partition is pretty full. It has around 45 GB of storage in it, and everything is great. However, let's say now as a customer or Contoso, we want to delete some historical data, either by deletion or by using TTL to expire that data based on the timestamp. If we do that, then you can see the partition layout stays the same, but now there's much less storage on each partition. At the same time, because I don't have as much data, I'd also like to lower my throughput. If I do that, if I lower my throughput from 50,000 to 10,000 here, I see that now I have some RUs fragmentation. I don't have as many RUs as anymore on each partition, and I also don't have that much storage. So what can I do to fix this? Okay. The answer is to merge your partitions, to use the Partition Merge feature. Partition Merge allows you to reduce the number of physical partitions in place, and Cosmos DB will automatically determine the right layout based on your current storage layout and RUs. So there's no calculations you really need to do here. All you need to do is point the API onto your container. So in this example, after we kind of defragment this collection, we can see we can actually fit our storage on a smaller number of physical partitions and have better throughput allowed on each one. This also has the benefit where if I'm running queries that typically need to talk to multiple physical partitions, if I have fewer of them, those queries can now run more efficiently as well. Okay. So let's switch over to the portal again to show you some metrics and a demo of how you can leverage this feature. So I've previously created a container called merge container. And as you can see here, just like an example, it has 5 physical partitions and not that much data on it. So I just use this metric called physical partition size, split it by physical partition ID, and I can see that I don't have that much storage on it. At the same time, I can use another metric called physical partition throughput that tells me how many request units, how much throughput is on each physical partition. In my case, I actually had set this to set this overall container to 50,000 RUs before. Now I lowered it to 10,000 RUs. So with 5 partitions, I have 2,000 RUs on each. Okay, let's see how we can actually defragment or merge this container. Okay. So we have both PowerShell and CLI capabilities available for this. But basically, all you need to do is run this what if command here. If you just want to see the preview of the results, and then if you remove what if, it'll actually run it. So here, I've actually run this command previously, where all I pass in is the name of the container, the resource group, and the account name that it's in, and say, based on the current settings of the container, what will happen if I do a merge? And the result here is that actually with this small amount of data, this can all fit into one partition with around 4 GB of storage. So just as a recap on best practices, this is typically something you want to do when your container has reached your steady state. So if you know you're going to be adding a lot of data in the future, or you know you're going to be scaling up a lot in the future, no need to worry about this. This is more for these scenarios where you've either scaled up really high and realize you need to scale down, or you've deleted a lot of historical data. As a best practice, set your RUs to the steady state that you want before you run the merge. Cosmos DB uses that as an input into the partition layout. So the more accurate information you give us, the better it will do. And also, in order to take advantage of this feature, you'll need to use the latest merge-aware SDKs. So on our documentation page, you can find the latest versions, which are compatible with Partition Merge. Let's just make sure that if you can run merge while your operation is running, and there's absolutely no impact to your production workloads. So in summary, we've covered 3 different tips you can use today to improve your cost and performance on Cosmos DB. Thank you so much for tuning in, and looking forward to see what you build with Azure Cosmos DB.